Hi, AP Calculus students. I had a request for these problems, 53, 69, 87, and 89 to be worked out from 5.4a. So here we go. Let's see, number 53. They were asking for the derivative. So let's see, y equals, so here's number 53, 2 over e to the x plus e to the negative x. Okay, now they are asking for the derivative. So you could do the quotient rule here. I think it's kind of a waste of time though, because the numerator is a constant. You'll be fine if you use the quotient rule, but I think what I'd rather do is keep my 2 and then write my denominator. Right, so this was actually a crazy looking denominator to the first power. So I think I will write it in the numerator to the negative first power. Okay, then I really just have a constant and a chain rule here. So I'm going to come on over here. And the derivative would be 2, right? The derivative of anything to the negative 1 power. So I'm first going to do the derivative of anything to the negative 1 is I bring the negative 1 out front and multiply it and reduce the exponent by 1 times the derivative of the inside function would be e to the x, right? Plus the derivative of e to the negative x is itself times the derivative of the inside function. There we go. I can make this look a little better by putting what's in the numerator and what's in the denominator. So in the numerator, I have a negative 2 and this expression, e to the x minus e to the negative x. And in the denominator, I have e to the x plus e to the negative x squared. So I have that this is my final answer. I'll do a quick check. Let's see, on number 53. It's my first math of the day. Yep, perfect. Okay. All right, let's go on then to problem number 69. Okay, on number 69, let's see. Use implicit differentiation. Okay, they are asking you to find the derivative of y with respect to x. So I will take the derivative with respect to x of both sides. Okay, the most difficult piece will be right here. We're going to use a product rule. The derivative of x is 1 times e to the y, plus I'm going to keep my x and multiply by the derivative of e to the y, which is itself times y prime, which is the dy dx I'm trying to solve for. The derivative of negative 10x is negative 10, plus the derivative of 3y is 3y prime, and the derivative of 0 is 0. Okay, I am going to keep any terms with a y prime on the left and get everything else to the right. Okay, I'm going to add a 10 and subtract e to the y. There we go. Now I can factor a y prime from the terms on the left. And then to get y prime alone, I'm just going to divide by the term above. I just don't feel like writing it twice. There we go. There we go. So this would cancel when I divide, and I would get y prime equals this expression. And again, quick check, right? Number 69. Let's see. Let's see how we're doing today. We're doing fabulous. Absolutely correct so far. Let's do number 87. Okay, on number 87, it says, find the area of the largest rectangle that can be inscribed under the curve y equals e to the negative x squared in the first and second quadrant. So area, largest triangle, largest rectangle, inscribed under y equals e to the negative x squared in the first and second quadrant, quad 1 and 2. Okay, so I think what would help me here is if I drew a picture for myself. So let's take a look. That would be, notice y equals e to the negative x squared is not really a function that I'm familiar with, okay? But I am going to go ahead, well, that's not even horizontal. I'm going to go ahead and help myself with the sketch of that. Now, without a doubt, with a base of e to the anything is positive. So that's why, like in the first and second quadrant here, it's not surprising that they're asking for the area of the largest rectangle inscribed between that curve and the x-axis. So let's help ourselves with some points. When I put a 0 in, that will be e to the 0, and I get a 1 out, right? When I put a 1 in, right? So when I put a 1 in, so when I put in a 0, I got a 1 out. When I put a 1 in, I get e to the negative 1, which is 1 over e, which is between like a half and a third, right? Because e is 2.781828. So about here. When I put in a 2, that would be e to the negative 4, which would be 1 over e to the 4th. So notice it's getting smaller, much smaller. Now, it will never hit 0, right? And so it looks like I have this kind of curve. Now, notice when I put in a negative 1, right? Here, negative 1 squared is 1 times a negative. I still have a 1 over e. Notice when I put in a negative 2, right here, a negative 2 squared is 4. Now it's a negative 4, and I get the same answer out. So it's not surprising that this function is symmetric over the y-axis because of the inside function being a parabola. So they're asking for, if I made a rectangle at some x here, let me see if I can make this a little bit more symmetric on both sides. And this would be obviously a negative x over here when I'm just as far from the x-axis on the left. They're basically saying, what's the largest rectangle I can make here? Okay, so when they say largest rectangle inscribed, right, it's on the inside, they're asking me to find a maximum, right? A largest area, the maximum of the area function, right? So if you remember that we've done that before, we can find max and mins. That is where the first derivative is 0 or undefined, right? Those are at critical points. Okay, so now I know what I'm doing. I'm going to write the area function, and then what I'm going to do is take the derivative of it and find where the derivative is 0 or undefined. And I'm going to make sure that that is a maximum. Now, of course, it's a maximum. It won't be a minimum because I know what the minimum area is. It's approaching 0, right? If I put x's way out here, right, then I have a large base, but an incredibly small height. And I could literally almost make that rectangle area approach 0. So when I do the critical points of the first derivative, that will be a maximum that I find. Okay, so let's write the area so that we can take the derivative of it. Okay, first I want to point out to you that the base of this rectangle, right, so I'm doing base times height, is 2 x's, right? It's 2 x's long, okay. Now, this is the height of the rectangle right here. And what is that height? Well, for any x I put in, that height is the y value, right? So this is the height of the rectangle. For any x I put in, this gives me the y and gives me that height. So the height is e to the negative x squared. So there's my area function that I want to maximize. Okay, so this means I need to take the derivative. I will use a product in a chain rule here. So the derivative of the area, the derivative of 2x is 2 times e to the negative x squared, plus I'm going to keep my 2x and take the derivative of e to the negative x squared, which is itself, times the derivative of the inside function, which is a negative 2x. Okay, let's clean this up a little bit. Let's see, I have a greatest common factor. Let's see, well, let's clean it up and then we'll pull out a greatest common factor. There we go. This is a negative 4x squared times e to the negative x squared. There we go. Okay, now I'm going to come on up. And the derivative is, I'm going to pull out the greatest common factor. I see a greatest common factor of 2 and e to the negative x squared. Of course, that will always happen because when you take the derivative of e to the anything, you get it back. So it ends up being a greatest common factor. Now that leaves here a 1. And that leaves here a 2x. Quick check to make sure that we're right? So let's see, when I multiply here, yes, I get the first term back. When I multiply here, I get it, there we go. Glad I checked, right? So let's take a look here. That would be a negative 4x squared e to the x. Yep, got it right. I was missing an x there. Okay, critical points. Let's go downward since that's where I have room. Undefined and equal to 0. Notice that the first term is never undefined, right? You can put in any x you want. The domain of e to the x or any form of that is negative infinity to infinity. Notice this is a polynomial, so nowhere is it undefined, so I'm going to put defined everywhere. Where is it equal to 0? Notice that this first term is never equal to 0, right? Only this polynomial can be equal to 0. Okay, so I'm going to subtract a 1 and divide by a negative 2, right? And x squared equals 1/2. And when I take the square root for a plus or a minus, that's where x is plus or minus. And when this is 1 over the square root of 2, so we're going to rationalize here. Okay, now what are the plus and minus x's for? Because this is a square root of 2 over 2 here, and the negative x, of course, is the negative square root of 2 over 2 x here. Now the question is did they ask us just for the x that would maximize the area of this rectangle, or did they ask us for the actual area of the rectangle? So let's take a look. And on 87, it says find the area of the largest rectangle. Okay, so this means here's my area formula here, right? And I'm going to take my x, the square root of 2 over 2, right, and put it into this area formula, right? So my area equals 2 times the square root of 2 over 2 times e, got to give myself some room here, to the negative square root of 2 over 2 squared. Okay, so that area is the 2's cancel, the square root of 2. Square root of 2 over 2 squared is 2/4, which is 1/2. So that's e to the negative 1/2. So this would appear to be the area of that rectangle. That was a heck of a problem, right? Really good practice for the AP exam to do a problem like that. They will, on the AP exam, are we correct? We are. On the AP exam, will they inscribe an area under a function? Yeah, you'll see one like that. It may not be as complicated as this because they don't want you to take up too much of your time. But they may give you more information so that you can move along more quickly. But you will see areas inscribed under functions. So let's go to problem number 89. Okay, on problem 89, it says, find a point on the graph of f of x equals e to the 2x, such that the tangent line to the graph, so that tangent line to graph goes through the origin. I use a graphing utility to graph it. Okay, I think what might help here is for me to draw myself a picture. So again, we've been given the graph e to the 2x, and they want the point on that graph that if I drew a tangent line there, it would go through 0, 0. So what does that look like? It looks like this. Okay, I know what e to the x looks like, right? So e to the 2x then, right, has the same shape, right? Or you could get points, make yourself a picture. But it basically says it still goes through the point 0, 1. And it is an increasing exponential function, so it curves to the right, right? And what they're asking for is they want a point on the graph of e to the 2x such that if I drew a tangent line, like I just did, that it would go through the origin. Now notice, and what they want is this point right here. That is some x and some y point, right? But I know what the y is. Any x on this curve, its y is defined as e to the 2x. So they're asking for us to find this point on this tangent line and the curve that where the tangent line goes through 0, 0. So there's two things I need you to know here. First of all, we have to bring the idea together that the slope of the tangent line is equal to the derivative at this point. Okay, so the slope of this tangent line is equal to the derivative at that point, yes? So let's find the slope of the tangent line on the left, right? So that would be y2 minus y1 over x2 minus x1. And that has to equal the derivative at this point. So let's take the derivative of e to the 2x. Here's the function, and let's take the derivative of it. That would be itself times 2. There we go. Okay, now we just have to find the x where this is true. Okay, couple ways we could go here, but let's go ahead and cross multiply. Couple ways to go. E to the 2x equals, I'll cross multiply here, 2x e to the 2x. Okay, well, I think what we might need to do here is get everything to one side and set it equal to 0, maybe do some factoring. So I have e to the 2x, and I'm going to subtract 2x e to the 2x and set this equal to 0. I'm hoping if I factor this, that I can better find the x where this is true. So notice I have e to the 2x in both terms. 1 minus 2x would be left equals 0. Now, first of all, notice that e to the 2x is never 0, right? So I only need 1 minus 2x to equal 0. Notice that happens where x is a half. Right, if I subtract a 1 and divide by a negative 2, I get x equals a half. So there we go. The x part of that point is 1/2. And when I put in the 1/2 here, right, 2 times a half is 1. And there we go. There is the point on the graph of e to the 2x where the tangent line goes through the origin. So I hope this is helpful to you. I'll post it in an update today so everyone can benefit from it, and have a great day.